Grounded. For over a century, the infantry soldier has been defined by the physical toll of their equipment. Traditional rifles and ammunition rely on brass and steel, materials that are not only heavy to carry, but retain blistering heat in the field. The logistical strain is just as heavy. Producing these metal components require massive, fixed industrial hubs, centralized factories that are difficult to move and easy to target. For Indonesia, this model creates a specific strategic risk. Defending 17,000 islands with centralized production on Java requires long, exposed maritime supply lines. If severed or blockaded, remote units are immediately cut off from guns and ammunition. In an archipelagic landscape, relying on centralized heavy metals makes a military supply chain brittle. PT Komodo Armament, a private defense firm based in Bekasi, is developing a solution to this geographic vulnerability. Their primary tool for addressing the weight of infantry gear is the Komodo D5 assault rifle. The core of the design is a shift in material, replacing imported heavy metals with advanced polymer composites in both the rifle and its ammunition. This material swap allows the military to decouple its supply from static, vulnerable infrastructure. This chart shows the weight difference in clear terms. Using polymer drops the rifle's empty weight from 3.4 to 1.5 kilograms. The ammunition follows this trend. Polymer rounds are 30% lighter than brass, allowing soldiers to carry more ammo or reduce their load. There is also a change in thermal behavior. While metals conduct heat toward the shooter, polymers act as insulators. The polymer casing prevents heat from transferring into the chamber. This eliminates the risk of cook-offs, where barrel heat causes ammunition to ignite unintentionally. To manage sustained fire, the D5 uses a handguard with open cavities. These pull heat away from the barrel faster than a solid metal guard. For soldiers in the field, these engineering choices result in a weapon system that is lighter, more reliable, and cooler to operate during prolonged engagements. While forging steel and brass requires massive energy and space, injecting polymer into high-precision molds is an efficient, low-footprint process. Because the machinery is smaller, Komodo Armament can utilize what they call decentralized high-mobility manufacturing. This means an entire production line for rifles and ammunition can be housed inside a standard shipping container. This new mobility allows the manufacturing process to shift from a fixed target into a deployable tactical asset. Relying on imported raw materials like brass creates a strategic dependency. Any disruption in global shipping can effectively shut down a nation's ability to rearm. By utilizing domestic polymers, the production process requires fewer foreign imports, narrowing the dependency down to only specialized parts like barrel blanks and optics. This focus on local materials has allowed the D5 to reach an 80% local manufacturing content rate. This supports the Indonesian government's efforts to reach self-sufficiency in defense production, as outlined in Law No. 16 of 2012. These domestic production lines bring Indonesia closer to the goal of regional self-reliance for its infantry equipment. When you combine lightweight gear with mobile manufacturing, the result is a new logistical model. If the main ports on Java are ever blockaded, these containerized factories can be moved by small boats or transport planes to bypass the threat. This allows soldiers on remote islands to sustain their own supply of rifles and ammunition directly at the edge of the conflict. This shift creates a new operational standard. The factory follows the troops. By utilizing the mobility of polymer manufacturing, Indonesia replaced its vulnerable centers of production with a distributed network designed to survive where traditional factories cannot.